if we obtain water by reacting hydrogen and oxygen or by heating magnesium bicarbonate, does the composition of water, that is, the proportion of hydrogen and oxygen in the water molecules, remain the same? Let us find out in this video. In 1799, Proust stated the law as, all pure samples of the same chemical compound contain the same elements combined in the same proportions by mass. He showed that irrespective of the method in which a chemical compound is prepared, it always has the same chemical composition. For example, we can prepare carbon dioxide gas by the combustion of carbon in the air, by the heating of calcium carbonate, or by the reaction of sodium carbonate with hydrochloric acid. 1 mole of a sample of carbon dioxide obtained from all these 3 sources is found to contain 12 grams of carbon and 32 grams of oxygen. Let us verify the law of definite proportions experimentally. Samples of copper oxide can be prepared in a laboratory from different sources. Source 1. Copper nitrate. When 3.08 grams of solid copper nitrate is heated, initially it melts in its own water of crystallization. On further heating, it decomposes to give black copper oxide. 2 molecules of copper nitrate decompose to form 2 molecules of copper oxide, 1 molecule of oxygen gas, and 4 molecules of nitrogen dioxide gas, which can be seen as brown fumes. This copper oxide sample A weighs 1.31 grams and is placed in a porcelain boat A. Copper oxide can also be prepared from copper hydroxide. For this, heat 1.05 grams of solid copper hydroxide. It decomposes to give black copper oxide. Copper hydroxide, upon heating, decomposes to form a copper oxide and water vapor. This copper oxide sample B weighs 0.86 grams and is placed in porcelain boat B. Another source from which copper oxide can be prepared is copper carbonate. Gently warm 1.64 grams of solid copper carbonate. It decomposes to give copper oxide and carbon dioxide gas. Copper carbonate, upon heating, decomposes to form copper oxide and carbon dioxide. This copper oxide sample C weighs 1.06 grams and is placed in porcelain boat C. These 3 porcelain boats are placed inside a hard glass combustion tube. The samples are heated. A current of dry hydrogen gas is passed over the copper oxide samples. Copper oxide and hydrogen react to form water vapor and metallic copper. When the reduction is complete, all the porcelain boats are cooled in the current of hydrogen for some time and then weighed. Copper in porcelain boat A weighs 1.05 grams. Copper in boat B weighs 0.69 grams, while that in boat C weighs 0.85 grams. On calculating the percentage weight of copper and oxygen in each case, we find that each copper oxide sample contains 80% copper and 20% oxygen. Thus, the law of definite proportions is experimentally verified. However, exceptions arise in the case of compounds prepared separately from different isotopes of the same element. For example, water, H2O, is made up of one O16 isotope of oxygen and two H1 isotopes of hydrogen, while heavy water, D2O, is made up of one O16 isotope of oxygen and two 1H2 isotopes of hydrogen. Water contains 88.89% oxygen and 11.11% hydrogen, while heavy water contains 80% oxygen and 20% hydrogen. Thus, we have seen that compounds prepared differently from different isotopes of the same element do not obey this law. To summarize, we have learned that irrespective of the method in which a chemical compound is prepared, it always has the same chemical composition. Thus, we have seen that compounds prepared differently from different isotopes of the same element do not obey this law. So far,